Hey everyone, and welcome. Today we're diving into a topic that's, well, everywhere, from figuring out cricket scores to planning your pocket money. It's linear equations in two variables. Now, I know the name sounds a bit heavy, but trust me, by the end of this, you'll see it's actually super simple and pretty powerful. So let's get right into it.
All right, so let's start with what you already know. You're pros at handling linear equations with just one variable, right? Something like 2x plus 5 equals 0, where you find that one single answer for x. Well, today we're just going to add one more letter to the party. That's it. It's the next logical step, and you'll see it lets us solve all sorts of new, interesting problems.
So you might be thinking, why do we even need a second variable? Great question. Let's look at a classic example from your textbook. Picture this, a cricket match. Two batsmen are at the crease, and together they've scored 176 runs. Now, how do we put that into a math equation? See the problem? We have two things we don't know: the score of the first batsman and the score of the second one.
And that's exactly why we need two variables. It's actually super simple. Let's just say the first batsman scored X runs and the second one scored Y runs. We know that together they scored 176, so X plus Y equals 176. Boom, that's it. This is a perfect example of a linear equation in two variables. We need both X and Y to tell the whole story.
Okay, awesome. Now that we've seen what these look like in the real world, let's learn their official name and format. You know, every type of equation in math has a standard form. Think of it like the proper grammar for a sentence. It just helps us recognize and work with them.
Here it is. ax plus by plus c equals 0. This is the blueprint for all linear equations in two variables. Let's break it down. The x and y are our variables, the things we don't know. The a, b, and c are just numbers. They can be anything: positive, negative, fractions, whatever. We call a the coefficient of x, b is the coefficient of y, and c is just a constant. Now, there's one little rule. A and b can't both be 0. Why? Well, if they were, the x and y would disappear and we wouldn't have an equation with two variables anymore. And fun fact, why is it called linear? Because if you were to graph it, it always makes a perfectly straight line.
Now, a heads up. These equations can sometimes show up in disguise. Don't let them fool you. Look at these examples. The variables don't have to be x and y. They can be s and t, or p and q. And the numbers, the coefficients, can be decimals like 1.2, or even something weird like pi. And check out that last one, 3 equals 2x minus 7y. It looks a bit messy, right? But it's still one of ours. We just have to do a little bit of rearranging to make it fit that standard form.
Okay, let's practice this. Let's take the equation 2x plus 3y equals 4.37. Our goal is to make it look like ax plus by plus c equals 0. What's the main difference? Well, the standard form has a 0 on one side. So, all we have to do is move that 4.37 over to the left side. And what's the golden rule when you move something across the equal sign? You flip the sign. So, it becomes 2x plus 3y minus 4.37 equals 0. See? Perfect. Now we're ready to pick out our a, b, and c.
So let's line it all up. Looking at our equation, 2x plus 3y minus 4.37 equals 0, it's super easy to match things up. The number with x, a, is 2. The number with y, b, is 3. And the constant term c is, watch out for this is a classic trap, it's negative 4.37. You've got to take the sign with it. That is so important to remember.
Okay, you're doing brilliantly. Now we're getting to what I think is the most interesting part of this topic. We're going to talk about the answers or solutions to these equations. And I'll give you a hint, it's probably not what you're expecting. It's totally different from the equations you've solved before.
So what does a solution even mean when you have two variables? It can't just be one number, right? Nope. A solution is a pair of numbers, a value for x and a value for y that, when you plug them in, make the equation true. They're a team, and we write them in a specific way, inside parentheses like this, x comma y. We call it an ordered pair. For a simple reason, the order is super important. The x value always comes first. Let's see this in action. Here's a question. Is the pair 3, 2 a solution for the equation 2x plus 3y equals 12? Well, there's only one way to find out. Let's check it. We just substitute 3 for x and 2 for y. So we get 2 times 3 plus 3 times 2. That gives us 6 plus 6, which is 12. And look, the other side of the equation is 12. It's a perfect match. So yes, for sure, 3, 2 is a solution.
Okay, so we found one solution, 3, 2. But are there more? Think back to our cricket problem, x plus y equals 176. The scores could be 176, right? Or maybe 90 and 86. Or what about 175 and 1? It feels like we could keep coming up with pairs all day long. So that leads to a really big question. Just how many solutions can one of these equations actually have?
And the answer is infinite. There are infinitely many solutions. This is probably the biggest, most important thing to remember from today. For a simple equation like 2x equals 10, there's only one answer, right? X is 5. End of story. But when you have two variables, you have an endless, infinite number of pairs that will solve it. Isn't that cool?
Okay, so it's great to know there's an infinite number of solutions. But that doesn't really help if we can't find any of them, right? So how do we actually do it? Let's walk through an example together, step by step. We'll find 4 different solutions for one equation just to get the hang of it.
All right, here's our mission for this section. We need to find 4, count them, 4 different solutions for the equation x plus 2y equals 6. Let's do it. Okay, the strategy here is actually really simple. You just pick a value for one of the letters, any value you want, and then solve for the other one. And what's the easiest number in the world to work with? 0. So let's start there. Let's just say x equals 0. Our equation then becomes 0 plus 2y equals 6, which is just 2y equals 6. Divide both sides by 2, and we get y equals 3. There we go. Our first solution is the pair 0, 3. Easy, right?
All right, for solution number 2, let's do the same trick, but for the other variable. Let's set y equals 0 this time. Now the equation is x plus 2 and 0 equals 6. Well, 2 times 0 is just 0, so it's x plus 0 equals 6, which means x equals 6. And just like that, we have our second solution, 6, 0. See how fast that is? Using 0 is a fantastic trick for exams.
But of course, you can pick any number you like, not just 0. Let's try something else simple, like y equals 1. We just plug that in. X plus 2 times 1 equals 6. That simplifies to x plus 2 equals 6. To get x by itself, we just subtract 2 from both sides, and we get x equals 4. And there's our third solution, 4, 1. See? The process is always the same.
Let's find one more to complete our mission. How about we pick x equals 2? Okay, let's substitute it in. We get 2 plus 2y equals 6. First, we subtract that 2 from both sides, which leaves us with 2y equals 4. Then, just divide by 2, and we find that y equals 2. So our fourth solution is 2, 2. And we could just keep going and going, but 4 is enough for now.
Fantastic job. You've really got the hang of this. So let's do a super quick recap of the most important points. And then I've got a killer exam tip for you.
So, what did we learn today? 3 main things. First, the standard form is ax plus by plus c equals 0. If you can make an equation look like that, it's a linear equation in 2 variables. Second, and this is the big one, these equations have infinitely many solutions. And third, every single one of those solutions is an ordered pair x, y that makes the equation work.
And now for that exam tip, which is so good it's taken straight from a remark in your textbook. When you're asked to find solutions, here's the quickest, easiest way to start. First, just plug in x equals 0 and solve for y. Then do the opposite. Plug in y equals 0 and solve for x. This little trick will instantly give you 2 perfectly correct solutions, and it'll save you a ton of time when the clock is ticking.
So, we found 4 solutions today, but we know there's an infinite sea of them out there. That leaves us with one last really interesting question to think about. If you took every single one of those infinite solution pairs and plotted each one as a dot on a graph, what would you see? What picture or shape would all those dots make? Give that some thought because that's exactly what we're going to explore next time. You did an amazing job today.